The third question I asked my friends was, what are some examples of nanotechnology or nanomaterials in your field specifically?
So nanotechnology in medicine is still an up-and-coming field. It's only about 10 years old, so we're still kind of working on getting it into the mainstream.
So nanomaterials are commonly used in drug delivery.
One of the really important things that nanotechnology is being applied to in medicine is the delivery of chemotherapeutic medications directly to our DNA.
Some nanomaterials actually can enter the brain where larger materials can't. This allows us to better treat mental diseases, things like Alzheimer's, dementia, etc.
So this is really important in the treatment of cancer because what we have for treatment now are standard treatments that are chemotherapy and radiation are really what we call cytotoxic. So that means it's going to do the job and kill the abnormally growing cells that we want to kill, but it's also going to still kill what we call the bystander cells, which are the healthy cells that surround maybe where the solid tumor is.
Basically, nanomaterials are so small that they can sneak past the brain's barriers and get into the brain where other things just can't.
And so when we can deliver specific medications to the DNA level with these nanoparticles, then we can pretty much eliminate any sort of cytotoxic effects because we're going to be cutting it off at the source. So we're not even going to give the cancer a chance to grow.
So my field is biomaterials and kind of bioengineering, but focus more on the material side of things. So I'm not dealing with things like proteins in your cells, like engineering those, but I'm making materials that then go and talk to those things and make them do things.
I'm a theoretical physicist.
Like I said, I'm a physicist.
I'm particularly excited about theoretical condensed matter, which is the study of materials that we can make and experience.
So let's go back to the periodic table. Each element on the periodic table represents a different kind of atom. And every material you can think of, I mean every single one, from wood to steel to plastic, is made up of atoms. Some materials, though, behave differently than others.
One very topical material is graphene, a single layer of carbon arranged in a regular hexagonal lattice.
I've also worked with carbon nanosheets, which are essentially these tiny two-dimensional sheets of carbon that are in the shape of these six-membered rings.
So you can think about a piece of paper. It's very flexible, it's easy to fold, easy to tear, easy to cut, and we like that about paper. It helps us make it in different sizes, do arts and crafts, whatever you want to do. But then if you think about a cell phone, this is not flexible. It's not very easy to just cut and tear and do whatever we want to do with it. But that's also a good thing. We don't want our cell phones to be so flexible that we can do this and it's gone. So different materials do behave differently, but that's a very good thing. We want materials to behave differently so they can be good for different jobs. But what is it about a material that makes one behave differently than another? That's where physicists come in. Love physics.
One amazing discovery that has the theoretical community raving is called the magic angle graphene.
Physicists can design different types of experiments to study why a material behaves the way that it does. So how are the atoms arranged inside? That usually involves using microscopes or lasers to understand the structure of the material, and are certain arrangements tied to special properties.
And by twisting two layers of graphene, we get a superconductor, a material that conducts electricity without any resistance. Have you heard of the hyperloop?
Is that the train? I actually don't know if I know what that is.
It's the train, it's
That's
the train. The reason why we need superconductors is transport, and instead of using kind of your car or anything, you could maybe transport people on really super high fast speed trains.
After we're done asking those questions, designing those experiments, trying to answer those questions, engineers can use that information to create nanomaterials that are very good at specific jobs.
I work a lot in the field of energy research. So in terms of energy, there are really a lot of things that are considered nanomaterials that I work with. For example, gold nanorods, which are essentially clumps of gold metal that are shaped into the form of rods that are only 80 nanometers long, for example. And they're really good at doing things like conducting electricity, and they're very promising for energy applications because they're a more sustainable way to improve the electronic properties of a material as opposed to using a more toxic or rare material like a rare metal or something like that.